Okay, welcome to Chapter 15, Section 1. Let's move right on into the key ideas here. What does a wave carry? How are waves generated? What is the difference between a transverse wave and a longitudinal wave? And how do the particles in ocean waves move? Let's move past the bell ringer. What's a wave and what does it carry? A wave is a disturbance in some kind of material that carries energy throughout matter or space. And actually it doesn't have to be matter itself, it could be empty space, but it is a disturbance that carries energy. So what is a wave here? You have like a wave motion. You've got water waves here where you have in this case a sinusoidal type wave where you've got up and down and up and down. You have a look like a leaf right here. As the wave moves across, you can see here it goes up, the leaf goes up the wave and then it goes back down the wave. The leaf doesn't actually move with the wave. The wave's just transferring that energy as it goes through, and that energy affects the leaf by moving it up and then down in its position. So most waves do travel through a medium being a physical environment in which phenomena occur. Basically, a medium is any kind of material, any kind of matter. Most waves will travel through some type of matter. Mechanical waves are a wave that require a medium. They require some kind of matter through which to travel. The examples of that are sound waves and water waves. Electromagnetic waves are a little different. They don't require a medium. Electromagnetic wave is a wave that consists of oscillating electric and magnetic fields which radiate outward at the speed of light. Electromagnetic waves are generally considered basically light waves. Visible light waves, radio waves, all of those things, and we'll get more into that. You'll have X-rays and gamma rays and microwaves and infrared and ultraviolet, and all those are considered electromagnetic waves. So to give you an idea about what an electromagnetic wave is, here let's watch this little video.
In classical electromagnetic wave theory, light is a wave composed of oscillating electric and magnetic fields. These fields are perpendicular to the direction in which the wave moves. Therefore, electromagnetic waves are transverse waves. The electric and magnetic fields are also at right angles to each other.
Okay, so it gives you a little bit information about electromagnetic waves. It's an oscillating electric and magnetic field, even though that's something you can't see. You just kind of see the effects of the electromagnetic or the oscillating electric and magnetic fields. So what transfers energy? Waves transfer energy, Tsunamis carry enough energy to cause damage to coastal towns. We saw that not too long ago in Japan, where tsunamis destroyed a lot of cities in Japan. The energy of normal ocean waves break up rocks into pieces to form sandy beaches. So all your beaches come from basically waves that have pounded against rocks, transferred that energy, broken them up. Now you have sand. So let's watch a little video concept here on tsunamis.
A tsunami is an enormous ocean wave caused by underwater earthquakes, volcanoes, or landslides. During an earthquake, the upward shift of the ocean floor releases energy. This energy pushes a large volume of water upward and creates tsunamis. As tsunamis near continents and interact with the ocean floor, they slow down. Their wavelengths get shorter and their height gets taller. Tsunamis can slam into the coast at heights that reach over 30 meters, devastating coastal communities.
Which is one of the things that happened in Japan. So, energy may spread out as a wave travels. When sound waves travel in air, the waves spread out in a spherical pattern. As the waves travel outward, the spherical wave front gets bigger, so the energy spreads out over a larger volume. So as the energy spreads out, what you hear, the further and further away, it gets less and less, the energy of that sound wave, so it doesn't sound as loud. So how are waves generated? Most waves are caused by vibrating objects. Sound waves are produced by a singer produced by a singer, caused by your vibrating vocal cords. As I'm talking to you now, my vibrating vocal cords are coming through this as sound, going into the microphone. It goes into the microphone, produces it into a digital signal into the computer. When it comes back out and you watch this video, and the speakers, they will vibrate similar to what vocal cords are vibrating, and you'll hear sounds from that, so you'll hear my voice. Electromagnetic waves may be caused by vibrating charged particles, and for mechanical waves, the particles in the medium through which the wave passes vibrate too. So the mechanical energy of a vibrating mass spring system changes form. So in this case, we have masses on springs. Here to the far left, the spring and the mass are still, so the mass is not moving. The person pulls on the mass and gives it elastic potential energy. As it's released, it gains kinetic energy to here where it is all kinetic energy, and then as it goes past, it starts compressing the spring and giving it more potential energy. And going all the way till it stops, which in that case it has no kinetic and it has all potential. Then it comes back out as it goes back toward the ground. It accelerates, it gains more kinetic energy. As it passes equilibrium point, it slows down and gains, as it's slowing down, it's gaining elastic potential energy again, and the process will repeat itself. And if you'll notice, this starts to form a wave-like pattern because of its oscillations or its vibrations. This type of vibration is called simple harmonic motion. A wave can pass through a series of vibrating objects. The disturbance travels down the row as energy is transferred from one mass to another. So in this particular case, you can do this where this object is moved and it vibrates, and as it does so, it will transfer energy down to these others where you'll get, since they're hooked together, you'll get a wave motion that will occur. And wave particles will move like the masses on springs. So what's the difference between a transverse wave and a longitudinal wave, and what are those? A transverse wave is a wave in which the wave motion is perpendicular to the particle motion. A longitudinal wave is a wave in which the wave motion is parallel to the particle motion. So let's look at it here. Transverse waves have perpendicular motion, a wave in which the particles of the medium move perpendicularly to the direction the wave is traveling, and longitudinals have parallel motion, a wave in which particles of the medium vibrate parallel to the direction of the wave. Here's an example that they're going to talk about here on transverse to give you an idea that the wave is moving to the right, but the little flag here, which is a particle in the wave, only moves up and down, which is perpendicular, so you see the right angle here, to the direction of the wave motion.
Transverse waves cause the particles of a medium to move in a direction perpendicular to the direction in which the wave is traveling. For example, a wave moving horizontally through a rope causes the rope and anything attached to it to move up and down as the wave passes through the rope.
Okay, so again, you see you have the wave direction going to the right, but the object moves up and down, which is perpendicular at a right angle to the direction of the wave motion. So now let's look at a longitudinal wave, which the particles move in a parallel direction, which parallel means in the same direction along the same lines in which the wave is moving.
As longitudinal waves move through a medium, they cause the particles of that medium to vibrate parallel to the direction in which the wave is moving. For example, a wave moving horizontally through a spring causes the atoms in the spring and anything attached to the coils to move back and forth.
Okay, so you saw here that as the wave moves from left to right in the slinky spring here, the object moved in the same directions back and forth instead of up and down like in a transverse wave. Waves have crests and troughs or compressions and rarefactions, depending on the type of wave. In a transverse wave, you have something called crests, which are the top of the wave, and troughs, which are the bottom of the wave, what we would consider. And then in the longitudinal waves, you have compressions, where the particles are close together, and rarefactions, where the particles look like they are stretched apart. So the crest is the highest point, trough is the lowest point, compression is the crowded area of the longitudinal, and the rarefactions are the stretched out areas of the longitudinal waves. So surface waves. How do the particles in ocean waves move? The particles in a surface wave move both perpendicularly and parallel to the direction in which the waves travel. So it's a combination of both transverse and longitudinal waves. So surface waves are waves that occur at a boundary between the two different mediums, such as water and air. So let's watch this on the formation and movement of ocean waves, which are a combination of transverse and longitudinal waves.
Wind blows across the ocean's surface, transferring energy to the water and creating waves. You may be surprised to know that while it looks like the water moves with the waves, only the waves move. Observe the motion of this bottle. As the wave crest approaches the bottle moves to the left and upward. As the wave crest passes the bottle changes direction and moves to the right and downward. As a wave passes through water, it causes water to rise and fall in circular movements, as shown by the movement of the bottle. The water, like the bottle, stays in the same place as the wave moves.
Okay, so that circular motion, you've got an up and down motion like in transverse waves, but you also have a forward and backward motion